Hello, my name is Paul. Welcome to my garage. In this video I would like to show you one very interesting method of diagnostic of the isolation for the cables, which is partial discharge indicator, which is available in SONEL MIC-15k1 meter. So this is a 15 kV isolation resistor meter. For the meters manufactured before 2023, it's required to do firmware update to have this feature. But to show this, I will, of course, I do not have the proper cable with some failure inside, so I will use the partial discharge simulator. So this is a cross section of the cable, and we connect the minus to the main core and plus to the shield, and inside there is a structure which simulates the partial discharge. Over here is also some place where will be visualization of the partial discharge by some diode blinking. First of all, what for we do this kind of testing? Of course, we can do only the measurement of the resistance, but sometimes the resistance value is proper, is good enough to decide that some object is well shaped, good shape. But inside the resistance happen some phenomena which indicate that sooner or later this isolation will be damaged. Of course, we can check the graph of the isolation through the time, and based on this determine if there is any moisture inside or some problems with isolation for the future. But partial discharge indication also gives some additional information if some phenomena of the partial discharge appears in the cable, and sooner or later this isolation will be damaged. So it's better to prevent than pay for some failures and additional cost for that. So how the meter do that? The meter checking the very short and small current changes, like transients, which is nanoseconds and nanoamps, so it's very short and small changes which meter can detect and present in the screen as a partial discharge counter. Beside that, it shows also the charge of the discharge in nano-picocoulombs. So let's see how it looks like. At the beginning, I need to set the meter. To do this, I need to press the menu button and turn on the meter. So this gives me the access to the hidden menu. So we can choose the frequency of the network which we measure. So choosing the right and left arrows will go to I will turn off the beep. So this is a V ISO set. So this feature allows us to set the voltage of the test voltage of the isolation during the measurement. So I will go on, press enter, the meter will turn on. Now when the meter is turned on, we have to choose this feature on a rotary knob. So it's allowed, this feature allows to put any voltage. If we go to the menu, right now it is 50 volts, so we can put any value here. For example, 1000 volts it will be. And we press enter. To start the measurement, we have to press start button and enter. So now the voltage will be 1000 volt, and we can increase this voltage by pressing arrows up and down. So you can see that I am changing voltage N, but for a few seconds isolation voltage will also increase to this value. By pressing F3 and 4 buttons, we can also see this is a partial discharge counter, and this is how much charge is covered by this partial discharge. Now it's less than 1000 picocoulombs, and on the simulator of the partial discharge simulator, we'll be able to see over here the small blinking. At the same time, the meter will be counting. Okay, now I have to change because right now the time of the measurement is 1 minute, so I will change to 2 minutes. Okay, let it be like that. So when I start the measurement, it will go to 1.5 kV. We can increase that, and we'll be checking how the simulator behaves. Oh, can you see the blinking over here? It was one blink. Now it's 1.8 kilovolts, so the blinking appears. 1.8 kilovolts. I will change. Now it's one counter show only one, so I will increase this value. Now we see the blinking is a little bit more, so we have counter is, it was for a few seconds it was 2. I will increase to 2 kilovolts. Now the counter shows 4, and the charge which we can measure is around 9000 picocoulombs, and you can see it start blinking even more. If I will increase the voltage to 2500, like you can see, there's more and more partial discharge. In the meter you can see 11, sometimes 12, and the value of the charge will also increase. 3 kilovolts. Now you can see that blinking, so the number of the discharge is increasing, so it is 17, and we can increase this value up to 5000 volts. Now it's already quite a lot, and we can see over here there's a 26, 27. The measurement time soon will finish, and the meter will stop the measurement, discharge the object automatically. So how you can see, now the meter discharged the object, decrease the voltage to a safety level, and you can see how much discharge it was, and still the value of the isolation, it was 6 mega ohm. So you may say that it's also it's not so bad, but thanks to this the discharge counter, we are able to determine that something wrong happening inside the isolations, so where we are not able to see how it looks like from outside. So thank you very much. If you have questions, please comment.